In this video, we're going to get started creating our enemy class. Before we begin, I want to clean up our scene. If you open up your scripts folder, we have our player and our player animation. Right-click your scripts and let's create a new folder to organize this. Call this player. This is going to host all of the player scripts, such as our player and player animation, and anything else we're going to create in the future. Drag it into the player folder, and we're good to go. Again, we're going to right-click our scripts, create another folder, and we're going to call this enemy. And this is going to be for all of our enemy-related classes that we create. Right-click your enemy folder, create new C# script, and let's create our enemy. Now, as discussed in our overview discussion, we're going to have one enemy class that defines all the shared traits amongst enemies. And then we're going to create individual enemy classes that will inherit from this base enemy class. So let's go ahead and set up the default values. You can think of this type of class as a blueprint for what defines an enemy. So let Visual Studios load up here. And we're going to basically go ahead and say public class enemy inherits from mono behavior. We can keep this. And let's remove void start and update for now. One of the things we have here is we're going to have our health, our gems, and our speed. So here we're going to say public int health, public int speed, and public int gems. We can also have an attack method that maybe we'll share. Public void attack. Let's save this. And right now, if we were to put this on an object, we would be able to define our own unique enemies. But what we're going to do is we're going to take it a step further by having individual functionality. A spider and our moss giant behave very differently. So we want to make sure that their behavior code is unique to them, but they share the most common properties. For instance, each one's going to have an attack method, and they're all going to have variables like this. Now, let's go ahead and save this, and let's create our moss giant. In our enemy folder, right-click, create, and create a new C# script. Let's call this moss giant. Once that's been created, double-click it to open it up in Visual Studios. And right now, it's moss giant inherits mono behavior. Instead, we're going to say inherits enemy. Save this, and let's head back into Unity. Right now, this is an empty class. But if I were to take this moss giant and drag it onto my actual moss giant character here, what's going to happen? So select your moss giant enemy and drag your moss giant script to the moss giant enemy. You'll see here that the moss giant script has a property here or variables for health, speed, and gems. How is that possible? Well, let's take a look at this. Moss giant inherits enemy, which gives it all the access of health, speed, gems, and attack. In my moss giant class, I can literally just type out here, if I was in a method like void start, I can say health, and I'm going to get my parent's health, and I can also type out speed as well as gems. I can even call my own attack method. So if we were to save this, and let's go into this attack method here, and let's do this, debug.log, and let's print out the name of the game object who's calling this attack method. So we're going to say my name is, and we're going to append this class's name. So this, we'll say this.gameObject.name. We'll save this. And what's going to happen now is on void start of our moss giant, it's going to call this attack function, which is shared here. And it's going to say my name is, and it should print out the object that called this object. Let's save this, head back into Unity, and let's run this game. You'll see here that in our inspector here, if we go to collapse, you'll see here that my name is moss giant enemy. So let's try another example. Let's create our next enemy. Create C# script, and let's call this spider. The spider is also going to inherit the enemy. So we're going to delete void start and update for now. Let's inherit enemy, and let's save this. Head back into Unity, And let's create an empty game object. Control-Shift-N. And let's call this spider underscore enemy. And drag the spider script onto the spider enemy. You'll see here that our spider and moss giant both have these same properties. For our moss giant, let's say the health is 5, speed of 1, and gems is 2. For our enemy, let's go ahead and say the health is 2, speed is 4, and gems is 1. You can see here that they have shared common behavior, but they're unique to themselves in their individual values. Let's go ahead and save this. Let's hop back into our spider script, and let's also call the attack method. So inside of void start, let's call attack. Let's save this, and let's run the game. What I'm demonstrating here is that the spider and moss giant are inheriting the base class enemy, and they're sharing common code, common functionality. Now, both of these objects attack very differently, and this is where abstract methods are going to come in, because we want them to have their own individual attack methods, but not necessarily use the base class implementation, although the base class implementation is always available. So if we had code that is shared amongst everyone, maybe they all have the same walk animation, or they all have the same waypoints, we can keep that in the base class. But if they have any behavior that's unique to the spider, unique to the moss giant, we have a dedicated C# script that we can add code, and it only affects that object. So in here, I ran our game, and you can see here that our attack function was called twice. My name is spider, and my name is moss giant. So although they both inherit enemy, they're individual. They have their own unique scripts that just grab those shared traits. So we only had to actually create those shared traits once, and now they automatically get them. So now let's also talk a bit about some of the access modifiers here. Right now I made these variables public, and everything is public here. Inside our game, do we want, for instance, the number of gems that an enemy receives to be changed? Or do we want an outside script to be able to modify how many gems I drop when I die? Probably not. So because it's public, I can access the enemy component and I can change this value. If I make it private, then only this value can be changed by the enemy. Now what happens if I want moss giant, for example? Let's say I want my moss giant to be able to access my gems. Well, you'll notice here that I can't. I can access my speed because it's a public variable, and I can access my health because it's a public variable. But why can't I access gems? Well, it's private, and private modifiers are basically making it so that only the enemy could modify this variable. If I want the child element to modify the variable but still keep it private to anyone outside, what we can do is change this from private to protected. This means that only the objects who inherit this class can modify it. So the enemy could modify this, and anyone who inherits enemy could modify it. If you're coming from an outside script, this variable won't be seen as it will be private for them. So if I go back into my moss giant here and I type gems, it's now available for me to change. So in my experience, it's always best practice for the most part to make these protected members, unless you know for sure you want them being accessed from an outside script, which in that case, you wouldn't actually just make this public. You would create a function. If you want to modify the health, create a damage method, and so forth. So this is the setup for our enemy here, and this is simple class inheritance. In the next video, we're going to take a look at turning this into an abstract class.